So let's talk about enabling OSPF for IP version 6 now. So if you've been following along with the videos, and if you've already seen the video of enabling EIGRP for IPv6, you're already halfway home. The process for configuring OSPF for v6 is almost exactly the same as what we already dealt with EIGRP. So this is going to be pretty fast. Once again, just like EIGRP, OSPF has not changed its message type. So the OSPF link state update, link state request, link state acknowledgement, all those types of OSPF packets we discussed already for IP version 4 are still irrelevant here for IP version 6. It still uses the exact same way of building the SPF tree and populating the link state database. Still uses cost as the metric and uses the exact same formula for cost. Still requires a router ID. So like I mentioned in the EIGRP v6 videos, with OSPF, if you've already got at least one IP version 4 address somewhere on your box, when you enable OSPFv3, which is OSPF for v6, when you enable OSPFv3, it will pull that IP version 4 address and use it as the router ID. If you have more than one IP version 4 address, it'll pull its router ID the exact same way we've already discussed when dealing with EIGRP and OSPF. It'll look to see if you have a static router ID configured first. If you don't have one, it'll look to see if you have any loopbacks. If you do have loopbacks, it'll pull the highest IP address from among your loopbacks. If there's no loopbacks, it'll pull the highest IP version 4 address from among your physical interfaces. And the process for neighbor discovery and building a full adjacency, all the same. So what's changed? Well, like EIGRP, OSPF forms a peering, a neighbor relationship using link local addresses. And for that reason, we don't need to have global addresses on the link at all. As a matter of fact, it's kind of interesting that with both EIGRP and OSPF, you could have a situation like this, where you have, maybe you've got a bunch of clients like laptops and stuff here connected to a switch. And that switch here is connected to, let's just say, router A. So we need some sort of global prefix for those clients, whatever that is. I'll just make up one right here. IPv6 takes so long to write. And then here we have A connecting to B. And we might have another switch right here with some additional clients connected to that. And so we're going to need a global prefix for these guys down here. But what's really neat about EIGRP and OSPF for IPv6 is that while our clients need a global IPv6 prefix, especially if they're going to be connecting to anything outside of their own network, we actually don't need any kind of global prefix right here. You see, in the world of IP version 4, in this very simple topology I've drawn, we would have needed a minimum of 3 networks. We need an IP version 4 network on the left, one in the middle, and one in the right. A and B would not be able to talk to each other via EIGRP or OSPF if we didn't have some kind of IPv4 network right here. But in the world of IPv6, that's not necessary, because we know that the moment that A and B have IPv6 enabled on these two interfaces, they will automatically derive for themselves link local addresses, beginning with FE80 something. And using just those, they'll be able to form their EIGRP or their OSPF neighbor relationship. So we don't even have to put a global prefix on that link at all. It's not necessary. Not that there's really any shortage of IPv6 prefixes, but it's just one less thing you have to configure. And also this last bullet point right here. Now at the CCNA level, like I mentioned in all of my discussions of OSPF for IP version 4, you don't have to know the different kinds of LSAs or what their names are, their numbers, or what they do. So you should just be aware that there are multiple kinds of LSAs, and when we go into the world of IPv6, specifically OSPFv3, those names have changed and some of their functionality has changed. That's all you got to know. You don't have to know the details beyond that. So how do we enable OSPF v3? Real easy. So step number one, actually I'm going to do this here. So step number one is to enable IPv6 unicast routing if you haven't already done that. Now, what I like to do is step number two is actually go right to my interface and enable OSPF on the interface, just like I did for EIGRP-v6. In this case, it's IPv6 OSPF and then your process ID. And unless you've got a really good reason for doing so, all of your interfaces should have the exact same process ID because your CPU is only going to be running one instance of OSPF. And then area, and then whatever area number this particular interface will be in. Now, in all of the routers and multi-layer switches we have here in our CCNA, CCNP racks I've been using for demonstrations, that's all I had to do. Once I did that, my global OSPF process was automatically created. I didn't have to do this. But like I mentioned, in some earlier versions of code, that was not necessarily the case. So sometimes even when you enable OSPF on the interface, it doesn't actually do anything until you go back to global configuration mode and you enable it right there as a global process. With newer versions of Cisco iOS, you should not have to do that, but with some older versions, you would. And also, if you need to manually set the router ID, if you don't have any IP version 4 addresses on your box, this is how you would do that. And that's it. That's really all there is for configuration of OSPF. And then as far as verification is concerned, it's all the same show commands that we already talked about. Just replace IP with IPv6. So let's just look at this real fast in the lab. So this is my topology. And in this particular case, I already have OSPF version 3 running on all the devices except for switch 2. So switch 2, which is going to be my area border router, is the only device that does not have OSPF version 3. Everything else is already pre-configured. So let's go ahead and do the configuration on switch 2 and then issue some show commands to verify it. One thing you'll also notice, at least I noticed this in the lab, is that when configuring OSPF for IP version 4, as soon as you hit the enter button, sometimes it takes almost a minute for the time for the OSPF adjacency to form. Even if it's a point-to-point Ethernet link, where it's two devices connected back-to-back via Ethernet, you know they've just exchanged hellos within a couple of seconds, and yet it can still take almost a minute for that neighbor relationship to fully complete and go into the full state. What I've noted with IPv6 is that it's like that. As soon as you hit the enter key, at least for me, that neighbor peering relationship happens so much faster. I'm not sure what the underlying mechanics are as far as why it's faster with OSPFv3 than it is with OSPFv2 for IPv4, but that being the case. So let's go ahead now and go into switch 2 and complete my configuration. So step number 1, make sure that I've enabled IPv6 unicast routing at the global configuration level. And then if we assume that I've already got all of my IPv6 addresses configured, which I'm not sure that I do, so here's a review question. What show command can I issue to see if I have any IPv6 addresses already configured on this device? Well, hopefully you said show IPv6 interface brief. And it looks like I've got an IPv6 address on Fast Ethernet 01, 016, and that's it. So I'm missing something. 01, 016, I'm missing the one on 0/3. Okay, so let's go into interface Fast Ethernet 0/3. IPv6 address 2001, and it's going to be 3232, 3232/64 EUI64. Okay, so now that I've got that, I'm just going to use the interface range command on these two interfaces right here to apply OSPF and put those into area 0. So that's 0/3 and 0/16. So it's IPv6, OSPF, my process ID, and then my area. And you'll see as soon as I hit the return key here, within just a couple of seconds, my OSPF neighbor relationships will be built. There you go. See how fast that is? It's amazing. So much faster than IPv4. Now I'll exit out. And now I'll just apply it on Fast Ethernet 0/1 for area 1, which will turn this guy into an area border router. Use the up arrow here to use my history and just change the area number to area 1. And then there we've got a full relationship there. Okay, so what are some of my verification commands? Let's see if I can verify that I have neighbors. I actually saw them in my syslogs, but let's say theoretically that I did not have access to those syslogs. Show IPv6 OSPF neighbor. And notice, even though we've peered with the link local address, this is showing our neighbor's router ID. Not the link local address of the neighbor's interface, but the router ID of the neighbor. And showing the state, in this particular case, all of my neighbors are designated routers for the segment in which I connect to them. And here are the interfaces where I connect to those neighbors. I can also do show IPv6 OSPF database to take a look at my OSPF LSAs for OSPFv3. And once you learn a little bit more about OSPFv3 at the CCNP level, you'll see that some of these names here are different than the LSA types that OSPF uses for IP version 4. Show IPv6 protocols. Great command to see what IPv6 routing protocols are running. In this particular case, we can see IPv6 routing protocol is OSPF. And it shows me the interfaces. Show IPv6 OSPF. Shows me my own router ID. It verifies that I am an ABR, an area border router. And then lastly, I could do show IPv6 route, which would show me all of my routes, or I could just limit it down to OSPF routes. And here we can see all the routes he's learned. Now, because this is an area border router, they are all intra-area routes because he is connected to both areas. But for example, if I go over here to switch 3, right here, show IPv6 route OSPF, we can see that he has learned some of those same routes as inter-area routes, because switch 3 is an internal router. He is internal to area 0. That's all he knows about. But these routes over here in area 1, he learned those as OIA, OSPF inter-area routes. And that's what we see right here, actually OI. And in IP version 4, it would actually say OIA, show IP route OSPF. See, we can see the difference. OIA for IP version 4 is equivalent to just OI in the world of IP version 6. And that concludes this section on OSPF version 3.